Good evening, YouTube. Welcome back to the channel. Back with another installment this evening of Python Koans series. Hope everyone had a good weekend. Happy Sunday. Getting ready for the workday tomorrow. Full weekend of kids' sports activities, some ice hockey. Got a good workout in, so I'm feeling pretty good. And I'm ready to work through some Python. So let's get to it. Here we are, Python Koans Master. Let me see, Python Koans Master. Let's contemplate koans, Python 3. Contemplate koans. All right, let me make this a bit bigger. I don't know why that dropped us directly into, oh, it was because the last time we did this, we were working with some debugging statements, and that means I must have left one in there. So thinking about control statements, let me just, about control, let's see, Command O, Command Shift O. What do I want to do here? Users, show top, programming, Python Koans, yes. All right, can I make this a little bit bigger? I can make that part bigger, okay. And then what did I say? About control statements. And is there a breakpoint left in here? Yes, right here. All right, so I'm going to go ahead and comment that out. And let's run it again. Get out of this thing, exit, Control D, Control D, Control C, Control Q, quit. Use quit. Man, this is painful. Okay. So let me clear the screen here. We are out of the debugger. That was exciting. Let me run this again as we would normally. All right, and we are on test break statement has damaged our karma. All right, so that would be on line 47 on that about control statements file. So let me just get rid of this. We talked about this in the last video. If you're interested, you can go check that out on how to use something like that to debug a while loop in this case. All right, so you know what? Let me just have that in case we need it, because it looks like we might. All right, so that'll be sitting there for us in case we need it. Test break statement. Okay, so a break statement. We have a variable on line 41 called I, and it's set to a value of the integer 1. Line 42, we've got a variable result set to an integer of 1. And then we have a while statement, a while loop, while true, and that means this will go into infinity if we don't break out of it, because true is always true. While true, if I is greater than 10, break, okay? Otherwise, take the result that currently exists and multiply it by the value currently held by I, and then increment I by 1. So each time we go through this loop, we will check to see if I has reached a point that it's greater than 10, and if it has reached that point, the loop will stop, and then the value of result at that moment will get returned. If I is less than 10, result will get a new value assigned to it, and I will get a new value assigned to it, and then we'll go through the loop again until we eventually reach that breakpoint. So let's go ahead and put our debug statement in here. All right. And then we can see what the values of I and result are as we go through this. So this breakpoint will hit right when the code, as it's running, hits line 45. All right, so we're going to go ahead and run this again. We would expect it to drop into an interactive console. And we are now, this console, scoped to whatever is in this context where it was triggered. And so what I mean by that is we can see the variables and their values as they exist inside this loop, and I guess theoretically outside. Okay, so let's see what I is currently. I is 1, result is 1. Okay? We can press Control D, I believe, to loop through again. And now we've come around the second time, and we've hit line 45 again in the loop. We assume that is because I is not yet greater than 10 and therefore hasn't hit that break term. Break function, I guess, might be a better way to say it. And therefore we keep going. So let's look at I and result again. So I is now 2 and result is 1 times whatever I was at the time, and that was 1. So that makes sense. All right, Control D. What is result now? What is I now? All right, so we've incremented I and result is now 2. So I is still less than 10 and therefore we haven't hit our break. Control D. I and result. All right, Control D. I and result. All right, so we're incrementing. I result, so I is now 6. I is now 7. I is now 8. I is now 9. Okay, so I is 9 at this current point. Okay, so we would expect it to go through again. Control D. Now I is 10 and result is that. So we have hit this point. I is currently 10, but it's not greater than 10. So I would expect this to go through again. All right, so Control D. I is now 11. And what's the result? Our result is this number. Okay, so I would expect we've gotten to this point. I is now 11. So when we hit this line after we press Control D again, we will hit this break. And therefore, no additional code, i.e. these 2 lines, will run. And then we will finally get down to the line where our assertion is. And we want to say, okay, assert equal, what 2 things, the value of result and then some integer that it's assigned to currently. The integer that it's assigned to currently appears to be 3628800. So let me go ahead and copy that, and we can test that theory. So if we save it and then press Control D, let's see. We are now on about control statements.py, line 49. Did I save it? Command S. Let's get rid of this. QUIT. All right, so where were we? So we got it correct. It looks like we got it correct because now, after removing the breakpoint or the stoppage we put in here, and allowing it to run through, we see that the error now shows us the next test is failing. So that implies that we've gotten the one we were just working on correct. Let's see, unless explicitly silenced. I don't know, that sounds cryptic, interesting. All right, so line 58, we made it to the next one. Test the continue statement. Okay, so another tricky one. Let's see. We've got a variable on line 50, I, set to a value of the integer 0. We've got on line 51 a variable result set to an empty list. On line 52, we start a while loop that says while I is less than 10, increment I by 1, and then if I modulo 2 equals 0, continue. Then append I to the result. Now, modulo 2, I believe, is going to be the way we check for whether it's odd or even. What does I modulo 2 check for in Python? All right, I modulo 2 uses the modulo operator. This operator returns the remainder of a division. Therefore, I modulo 2 calculates the remainder when the variable I is divisible by 2. And therefore, when it is even. This operation is commonly used to determine if a number is even or odd. If I modulo 2 evaluates to 0, it means that I is evenly divisible by 2, and thus I is an even number. If it evaluates to 1 or any other non-zero value, it means that it's essentially an odd number. So, in the while loop, we say if I is less than 10, keep going, increment I, and if I is divisible evenly by 2, if it's an even number, continue on and append that value of I to the result hash. And we'll go through this until I is 10 or greater, and then we'll break out of the loop and we'll see what comparison we have. So let's go ahead and we'll just drop our, again, our breakpoint code in there, and we can watch it as it steps through. So let's go ahead and do that and get rid of this. All right, we got our breakpoint. And let's run it. Python, okay, so currently, what is I? I equals 0, and result, I assume, is going to be an empty list. And it is. All right, so Command D or Control D. I is now 1, result is 1. Okay, so does 1, wait a minute. I'm just curious. What is 1, what is 0 modulo 0? Integer modulo by 0 What is 0 modulo 2? 0. All right, what is 1 modulo 2? 1. Okay, so, oh, I see. So when I was 0, we came through. We incremented I by 1. And then if I percent 2, modulo 2 equals 0, continue, and append I. But if I was 1, why would this work? And why would we get to here? Because I is 0. We get to here, line 54. Now I equals 1. And then we say if I percent 2 equals 0, continue. Otherwise, append I. Oh, I wonder if continue actually means skip everything below. Ah, I think that's what it is. That's tricky. I wasn't interpreting it correctly the first time. If I is even, continue on to the next loop around. Don't do anything. If I is odd, evaluate the next line. And because we got to here and I was 1, we incremented it for the first time to 1. This evaluated to 1. 1 modulo 2 equals 1. And therefore, we didn't continue, meaning we didn't immediately jump to the next loop around. We appended. So what's going to happen is we're going to only append odd numbers to our result list. Okay. Tricky. So let's go back around. We'll check what I is now. So I is now 2, and result is only that. And then I would expect it to stay that way. I is now 3. Result is 1 and 3. Yeah, this makes sense. Okay, we're just going to get the odd numbers placed into our result bucket. Go around. I is 4. Result is now the same because that 4 is even number. All right, and then we're going to get 3 items in our list. Yep. Result. 4 items in our list. Same. All right, now, before I do this, I is currently 9. Breakpoint when I is less than 10, so that's going to work. Okay, but then once we get to 10, while I is less than 10, okay, we aren't going to hit this breakpoint again. It's going to jump right here and throw an error because we don't have anything in the assertion. So let's try to fill it in preemptively. And let's say it's 1, 3, 5, 7, 9. I think we get that far. We may just get 1, 3, 5, 7. Let's see what happens. So result is 1, 3, 5, 7, 9. Now I feel like we should get to the end. All right, now it's kind of screwy because I have this breakpoint in here. So let's comment that out again, run it, see what it does. All right, we did it. So that was that one. Pretty interesting. So the key thing there is that control, or that continue keyword. Break is like, if you meet the condition right before me, stop and don't do anything else. Continue is, if you meet the condition right before me, go back to the start of the loop. However, if you don't meet the condition right before me, continue evaluating the rest of the loop. All right, so we can control the flow of the program using logic like that. And this is a common one. This modulo thing appears all the time in interviews. You know, some of the classic interview problems around, you know, finding all the odd or even numbers in a list, or manipulating lists with odd and even, etc. So something to definitely be aware of. That's like a basic operator to be aware of. All right, next up. So test for statement. Okay, let's see what this is about. We've got a list with 3 strings, fish and chips. We've got a variable called result set to an empty list. All right, and now we're going to say for item in phrase, result, append to result, item dot upper. All right, so I assume that upper here means uppercase. And I don't know if it means all uppercase or just the first letter uppercase. So let's go ahead and try it. But this is the key part, the key new sort of logic that we want to talk about, which is this for loop. And we're going to say for item in phrase. Now, one thing to keep in mind is that item is a variable that is going to be set to the value each step along the way in the list. The value of wherever it is in the list. So it's going to step through the list of items in phrase, and it's going to get to the first one. And in this moment, item at line 60 will be the string fish. And then as it goes again, it'll be the string and then the next one will be chips. Item is anything we want to call it. We're just putting a stand-in variable name to be able to call methods on whatever is in that position at that moment. All right, so in this particular case, go through each item in the list phrase and take that thing, call the upper function on it, and then put the result of having called the upper function on that item into the result list. So let's see, I'm going to make a guess. I don't know if it's going to be fish or if it's going to look like, I'll show you on the last one here, if it's going to be all caps or just the first one. I don't know. It's hard to say. Hard to say which one it is. Let me get that out of the way. And let's try to run it. All right, it looks like I was incorrect. It's going to be all caps. So that's kind of sucks, but whatever. Fish and chips. All right, let's save, try to run it again. And that is good. Okay, we're at the line 77. All right, that's going down here. Oh man, this is a big one. Okay, so there we go. Another test. Test for statement with tuples. Okay, so we've got a variable, round table, set to a list of tuples. And each tuple has a list of strings inside. So a list of tuples containing strings, containing a couple or, two strings apiece. All right, Lancelot blue, Galahad, I don't know, Robin blue, I mean green, Arthur, is that an African swallow or European swallow? Okay. What I was going to say, it's bad that I don't know, that I can't remember the name of this movie. Monty Python. Man, that's pretty bad. Okay. Then on line 71, we've got a variable called result set to an empty list. All right, so what do we do here? On line 72, we say for night, comma, answer in round table. Result, append. Contestant, whatever night is, answer, whatever the answer was. Okay, so it looks like what's happening here is, this is interesting. Okay, so what's happening here? First of all, this construction. So in our for loop, we don't just have the ability to have one item or one variable as we go across our list. We can actually have two. And so what it looks like it's saying is, I'm going to go through each item in the list. And as I go through, when I get to my list item, my first variable will be set to the first item in the tuple. And my second variable will be set to the second item in the tuple. And then we're going to interpolate, since they are all strings, those values into a longer string. And we're going to create a large string using the interpolated values of night and answer at their time as they go through. And we're going to append that to result. And then we're going to say text equals something. And then we're going to say self assert regex result to text. Okay, so let's first of all work on our result. So we're going to say contestant Lancelot, answer blue. Contestant Galahad, answer I don't know. Contestant Robin, blue I mean green. Contestant Arthur, answer is that an African swallow or a European swallow? So I think once we've done all that, we're going to have several strings. Let's go ahead and try to format this to look like it should. I think something like that. Okay, so let me just okay, and now Galahad, answer. I don't know, exclamation point. Answer Robin, or contestant Robin, answer blue, exclamation point. I mean green. And finally, contestant Arthur, this is how this is going to look. Answer. Okay, so I think after we go through our for loop, result will look something like this. So let's go ahead and comment that out. We will put our, did I get rid of the breakpoint code? I sure did. Okay, whatever. Let's go ahead and run this. And let's see. Okay, so tuples with I mean green. Oh, I see. Yeah. Okay, so let's say this is what result looks like. Then now we're going to say the item at the second index of result, and we're going to compare that to text. All right, and so text is going to be something different every time, which is kind of interesting. So let's fill in the correct text maybe, or let's just put one here just as an example. So remember, these are zero based, so we're going to say this last one is going to be the one I think in question here, 0, 1, 2. Text is that. All right, let's see what it does with this. Does it get to line 15? No. Oh, I see what happened. Okay, yes. These are assert not regex. So make sure that these three don't equal what's in text. And what is in text is this string, the item at the second index of the list result after the code is run. So we were correct. We got to the result that was generated, and the correct one placed in text at line 80 allowed all these assertions to pass. And as a result, we are now over on to the next file. Let me jump in there and I'll do a couple. So I'm going to go ahead and save this. And I'll do a couple. So let's see. About true and false. So let me do about true and false.py. All right, starting again. Here we go. So we are in a new file, a new Koan with a class about true and false. We've got a method here, truth value, that looks like it takes some condition. And if that condition returns, or if there is a condition, or if it returns true, if that condition is truthy, return the string true stuff. Otherwise, return false stuff. Okay, so here we are on line 14. We've got a test. Test true is treated as true. All right, assert equal true stuff. So what is it going to say? When we pass true, the Boolean object true, to the method truth value, which is defined right up here, if that thing evaluates to true, we're going to return true stuff. And I believe it will, since it is the Boolean itself true. And therefore, I think that we're going to be comparing what the result is if this condition is met. And remember, this line says, does the thing that I'm looking at right now resolve to true? And it, in this case, does, because it is the true Boolean itself. So let's test that theory. All right, we're to line 18, so that was correct. Okay, so test false is treated as false. All right, so when we pass false to our truth value method, I can hear my son upstairs screaming and doesn't want to go to bed. If we pass false to our truth value function, and we get here, and we say, okay, is the thing that I'm looking at now, does it resolve to true? I think not, because it is the opposite of true. It is the Boolean false. And false resolves to not true, or false resolves to false. So I believe what is going to be returned in this case is the string false stuff, because this if condition is not met, and therefore we get to the else, which returns the string false stuff. So let's try that. That worked. We'll do two more. Test false is treated as false. We just did that. Test none is treated as false. Okay, in Python, it looks like we've got this keyword none. And in my experience with Ruby, things that are empty, things that are none, like things that are none or negative, you know, these sort of negative, negation, lack of items, etc., typically I think resolve to false. And so therefore, I think we're going to get the false stuff string returned by our truth value function. So let's test that. That is correct because we got to line 24, so we're moving along. All right, last one. Test 0 is treated as false. Again, lack of something, negation. Typically, these types of things resolve to false. All right, so I would expect 1, for example, or anything non-zero to result to true, which FYI. So again, because this thing resolves to false, false stuff string is going to be returned by our truth value function. So let's go ahead and test that theory. And that was correct because we are on line 27. All right, what the heck? Let's just finish up the file. All right, here we go. Line 26. Test. Empty collections are treated as false. All right, so again, I've said it several times, but emptiness, typically false. So empty list, empty tuple, empty hash, or dictionary, I think is the correct term. Empty set. Looks like all these are going to return, instead of doing that 4 times by hand, I'm just going to copy once and paste. And there's actually probably an even smarter way to do this in Sublime Text, but this is fine, whatever. All right, so let's test that theory. Saved it and run it. Okay, we're to line 33. Yes, all of those correct. Test that blank strings are treated as false. Again, same thing, emptiness, blank stuff. Typically returns false. Finally, test everything else is treated as true. Everything else is treated as true. Okay, literally everything else. So we've got, in closing, true returns true. False, none, 0, and anything empty, including an empty string, return false. Everything else returns true. Okay, so when you want to control logic, control the flow of the program using Booleans or things that result in Booleans, really when it comes to false stuff, you only have to remember a handful of things, including the Boolean false itself, none, 0, and anything empty. Everything else will return resolve to true. All right, so let's go ahead and fill these in. True stuff. All right, good. Let me do, let's see, highlight this, Command D will highlight them all, backspace once, paste once, and let's see. And now we are in a different file. So those are all correct. All right, that is it for the evening. Thank you for attending this installment of Python Koans. Let's see, how far along are we? Completed 103, 11 out of 37 lessons. You're now 201 koans and 26 lessons away. So 33%. We're a third of the way done. Not too bad. All right, hope everyone has a good week. Thanks again. Thanks for being part of this channel, and it continues to grow slowly and surely over time. I'm still really enjoying this. A lot of the networking stuff, this stuff has been a lot of fun. I've been thinking about what language we might do after these, and there are some lower level languages I'd like to demonstrate using the same Koans method. So be on the lookout for that as we get closer to the finish line for these, but we'll wrap these up before we do that. Let's see, in closing, although never is often better than right now. It's kind of weird. I don't know if I'm supposed to be seeing more. These kind of like pop in sort of out of context, but always interesting little tidbits. Although never is often better than right now. Something to think about. All right, everyone have a good night, and I'll see you all soon. Thanks. Bye.